Number 1. The checkbook shows one's bank account balance at the beginning of the week. The checkbook shows that he has $100. It says during the week he withdrew 19. Withdrawal is taking out. Depositing is putting in. So he withdraws $19 and then he withdrew another $30. That is one way you could have written that sentence. Now, a second way could have been he had $100 and he took out the sum of these two withdrawals because that's how much money total he took out.
Hey, what if it's the other way? The first, the
30 plus 19 is the same thing.
Okay.
Also, if you're writing in terms of the negative numbers that we've been using, it could have been that you are adding a negative 19 and another negative 30 to end up with 100 plus a negative 49 to give us a positive 51. So when you actually solved it, it wanted to know how much money does he have left at the end of the week. All of these would have given you a positive $51. Now, number 2 wanted to know how your two were different. So all you had to do was write a statement about how the two number sentences that you wrote were different. This one subtracted them out individually. It subtracted each one out individually. This one subtracted the sum of the withdrawal. And this one used negative numbers. So you just had to look at the two different ways that you wrote your number sentences. And number 2 was just asking for a description. How were the two that you chose to write, how were they different? B was wanting you to turn these that were in factored form to expanded form. So we're going to distribute the number on the outside to all the numbers on the inside. So 5 times 3 plus 5 times 2 is what you should have written for number 1 on that first line. It only wanted you to turn these factored forms into expanded form. Number 2, 5 times 3 plus 5 times negative 2. Turning this factored form into that expanded form. Yes.
For number 2, does it matter if you put your negative 2 in parentheses?
No. 5 times 3 minus 5 times 2 5 times 3 minus 5 times negative 2. Number 5 wanted you to solve 1, 2, 3, and 4. Well, not so much to solve it, but to find the answer, the value of it. Because it doesn't have any variables in it, then we can. we can solve the ones that were given to us. So, following the order of operations, you have to multiply first. So, 5 times 3 is 15, plus 5 times 2 is 10, 15 plus 10 is 25. So, the answer to number 1 is going to be 25. Number 2, 5 times 3 is 15, plus 5 times negative 2 is a negative 10. Because you multiply, the signs are different, it's a negative. When you are adding and the signs are different, you subtract. 15 minus 10 is 5. The higher one is positive, it's a positive 5. Number 3, 5 times 3 is 15, minus 5 times 2 is 10. 15 minus 10 is a positive 5. And then the last one, 5 times 3 is 15, minus 5 times 2 is 10. Different signs, a negative 10. You have to keep, change. 15 plus a positive 10, that's a positive 25 for the last one. So we wrote our expanded form for the first part of B, and then we solved them for number 5, second part of B. Any questions about any of those? C was giving us our expanded form and wanted us to turn it back into the factor form. So you got a chance to practice both. So looking at C, for number 1, what number is your multiplier? 6. This is the number that had been given to both. So that's the number that goes on the outside of the parentheses. Then what goes on the inside is 2 plus 3. And then you close it. What number is your multiplier in number 2? 6. 6 is here, 6 is here. So 6 is the number that goes on the outside. Then what goes on the inside is 2 subtract 3. What's your multiplier for 3? Negative 6. So negative 6 goes on the outside this time. Then 2 plus 3. What's your multiplier in 4? Negative 6. And then 2 minus 3. Now for this one you have to look at it as 5 times x minus 8 times x, and what's your multiplier? X. X goes on the outside. Then 5 minus 8 on the inside. What's your multiplier for number 6? X. X goes on the outside. Negative 3, subtract 4. Goes on the inside. So now that was giving you practice taking the expanded form and turning it back into the factored form. Number 7 wants you to explain how to factor an expression with subtraction in it. So let's look at this one, 6 times 2 minus 3, because that's subtraction. So I want you to, for number 7, come over here and write that 2 times. 6 times 2 minus 3. Write it 2 times. Now, I know that with subtraction and with integers, I'm supposed to keep change. So you can do that right here. I know we didn't do it when we were over here. We didn't do it in A before we solved. But you can go in here and keep change and do add a -3. That's where it's the most common sense or reasonable thing to do, is to go ahead and change it. And then distribute. Then we would go 6 times 2 is 12, plus 6 times -3 is -18. Then our signs are different, so we subtract. 18 minus 12 is 6. And the higher absolute value is negative, so it's a -6. So in this particular one, I took care of my subtraction up top. That was the very first thing that I done. If you don't take care of it there, you've got to take care of it somewhere else. And we did that in B. We did that in B. So if we have to take care of it somewhere else, then this is where it's going to have to be. 6 times 2 is 12. Subtract 6 times 3 is 18. Now I still have subtraction I've got to take care of, because I didn't take care of it in the parentheses. So now I have to keep change, and it's supposed to still look like it's supposed to. Now that these are different signs, we subtract 6, higher absolute value is negative, -6. You're going to get the same thing. But training yourself to think algebraically, you're always solving by taking care of subtraction first. You're changing all of your subtractions with that algorithm of keep, change, adding the opposite. So it's a lot better to do it here so that you already know what you've got as you continue to go down in your problem. Because this is just the beginning. You're going to have problems that look like and you have to simplify that. And that's a 7th grade problem. So there may be subtractions in here that you've got to take care of from the beginning. Once you have it all factored out, all of your x's have to be put together and solved. All of your regular numbers with no variables have to be put together and solved. Well, that's called combining like terms, and that's the next thing that you would have to do. So that's where this is going, is being able to take problems that are like this and being able to understand what you've got. If you know that that's this amount 6 times, and you have to put this 6 times and add them, then that's what you do. If you have to write this amount 4 times and then add them, then that's what you do. And then take those two answers and combine those terms together where you need to. So different ways that we'll see to solve them, and different ways that we'll practice to solve them. But this is what it's leading up to for you to be able to distribute and then later combine like terms using your integer rules. So always going back to you having to know your integer rules. Are there any questions about A, B, or C that we've already done together? Basically, this looks at factored form, expanded form, being able to simplify it right now to what you can do. And of course, we'll have to start learning how to simplify even more when we start doing that thing called combining like terms. Look at the next page for me.